Let me know when you're ready. Hey, by the way, how do I look?
You've never looked better.
All right, you ready?
Yeah.
Okay. All right, Math 8. Let's get this party started right. We're silly, I know, but it's late. Okay, let's correct that piglet from the other day. We've got page 61 through 62, 1 through 21. Okay. Let's put some big ol' answers up there. There we go. Remember, I'm not going to spend all day on this because you can freeze it and go back and look at these. Remember, they're asking for the two square roots, the positive and the negative, for all of these. The square root of 10, we're gonna go look at this one right here. Square root of 18, we're gonna look at that one. The rest of these are, square root of 4 is 2, square root of 25 is 5, and the negative version. 225 is 15, and the negative version, negative 15. Square root of 1 is 1, square root of 49 is 7, and the negative. So the principal and the negative one. Okay. Let's go 5 and 6, and then we'll look at the rest of them. All right. We've done this a couple of times recently. Square root of 10. Okay, let's take a look. Oh, I think I broke my little toe about 10 minutes ago. I broke the other one, I think, about a week ago. This has been an awesome day. Awesome week. Okay, so square root of 10 sits in between two perfect squares, 9 and 16. 9 is 3, 16 is 4. So, from 9 to 10 is plus 1. From 9 all the way to 16 is plus 7. So it's 1/7 of the way there. 1 divided by 7, I know it's 0.14, so I would say it's close to 3. So if I start squaring some stuff, I'd probably take 3.1 squared and 3.2 squared. And we're looking for 10. So what's closest to 10? 9.61 is 0.39 away. And from 10 to 10.24 is 0.24. It's closer to 3.2. And that's my guesstimate. So 3.2 and the negative 1. Negative 3.2. It's approximate, but it's pretty close. Okay, number 6. Square root of 18 sits in between the square root of 25 and the square root of 16. Whichever way you go, it doesn't matter. Let's say I went 16 and I went 16 is 4, the next number up is 5, and if I squared it, I'd get 25. Okay, so I know it's between 4 and 5. Well, from 16 to 18 is plus 2, and from 16 to 25 is plus 9. It's 2/9, and actually in my head, I do this. 9 times 11 is 99, and 2 times 11 is 22, and it's 22 hundredths. 22 hundredths is 0.22, I'd say 4.2. I don't know if this helped or not, but let's see. So I'm thinking it's 4.2. So that's where I started, 4.2. 4.1 is probably too small. Remember, we're looking for 18, and you're at 16.81, so I crossed it out. 4.2 squared, 17.64. 4.3 squared, 18.49. From here to here is 0.36. And from 18 to 18.49 is 0.49. It's closer to 4.2. I don't know if this part helped, but if it's 2/9 of the way there, 2/9 is like close to 2/10, 0.2, however you get there, you're squaring some stuff. You come over here and you start squaring. If you start maybe swearing too, hopefully not, but anyway, you squared 4.1, 4.2, 4.3, and you go, oh look, 18 fits in between these two numbers. And I'd say it's either 4.2 or 4.3, and we rounded it to 4.2 because it's only 0.36 away. From here to here, it's only 0.36. It's closer. So we went with 4.2, and there we go, the positive and the negative. Hope that helped. Okay, let's see. Number 7. Remember I told you, I'm not going to say his name, but Mr. Heisman's shortcut, he said if you got a repeating decimal, not one digit, put that digit right there, one digit, 19 on the bottom. And if you can reduce it, reduce it. If there's 2 digits, put 63 over 99, 2 nines. Reduce it if you can, divide them both by 9, you get 7 over 11. Number 9, you've got 3 digits, put 214 over 999. So 3 repeating digits, put it over 3 nines. 2 repeating digits, right here, put it over 2 nines. 1 repeating digit, right here, put it over 1 9. One of these nines, in other words. Put that 5 over a 9. Make sense? Okay. And then can't reduce this. Alright, let's go to number 10. They wanted you to solve this equation. So you're taking the square root of both sides. Okay, now we're going to assume that it's a perfect square. So I would say, alright, square root of both sides. 361 is close to 400. I thought I had it written down. Maybe I don't. 361 is close to 400. And the square root of 400 is 20. So I'd probably try 19. Remember I said if you squared 19, 9 times 9 ends in 1, and this number ends in 1, I'd probably try 19 and see what happens, and I work my way down if it didn't work. Hopefully it's a whole number, and it is. So if you squared 19, that's your answer, 19. Because 9 times 9 ends in 1. That's a shortcut. Let's take a look over here. Now they want the cube root. Okay, there's a shortcut for that too. So you're taking the cube root of both of them. They don't show it that way, but that's what you're really doing. And something times something times something. So if you did 10 times 10 times 10, that's 1,000. 20 times 20 times 20 is 8,000. That's way too big. So it's going to be close to 10. And if you said, watch, 11 times 11 times 11, 1 times 1 times 1, it's going to end in 1. You see how the number ends in 8? If it's going to be a whole number, let's try 12. See how 12 times 12 times 12? I would say 2 times 2 times 2 ends in 8. That's probably going to be the number. You're saying 12 times 12 times 12. And if you multiply the last digit times the last digit times the last digit, I think it works every time. It seems like it does. Maybe not, but that's something I try anyway. Otherwise, you're going to say 10 cubed is 1,000. Let's try 11. 11 cubed is whatever, not big enough. And if you went to 12, the next number up, 12 times 12 times 12. 12 squared is 144. 144 times 12. You would get 1728. So the cube root of 1728 is 12. Hope that helped. Okay, then you're saying solve that equation, take the square root of both sides. That's going to be x equals, what's it going to be, 7 over 11, because 49, the square root of 49 is 7, square root of 121 is 11, so 7/11ths. Okay, so we're going to go to, that was 12. Okay, on these, remember the chart, it went real, was the blanket that covered everything, that was real. Then it was rational and irrational over here. That chart that we had, they go backwards. They go from down to the top, which is real. I would go real and then rational. Real, rational, integer, whole number. I would go from left to right the way they have it. They have it backwards. I don't know why they do, but they do. So I like to go. Let's see if I can find that stinking chart. Oh, there it is. You see how it's real numbers, and there's rational, and there's irrational, and then you go down from there. They go backwards. Don't know why, but it's crazy. Okay, so 2/3 is a real number, because they're all real numbers, and it's rational because you can write it as a fraction, and it's also 0.666666666 forever. It's a repeating decimal, so it's also means that it's rational. Number 14, that answer would be the square root of 100 is 10. They want the negative one, so it would be a real number, it's a rational number, and it's an integer. Whole numbers are positive, so it's not a whole number. Okay, number 15, that's 3, so it's a real number, it's a rational number, you can write it as a fraction, it's also a whole number, so it's an integer, positive and negative whole numbers, and it's a whole number. Square root of 21 is not a perfect square, so it's a real number, but it's irrational. You're so irrational, you just don't make any sense. Alright, let's see here. Number 17. Okay, these are kind of confusing. So I got pretty close. They might even be the exact square root. Let's see, square root of 7. 7 square root 2.64, so 2.6, and I'm assuming that's the square root also. So square root of 5, 2.2, yeah. So I got basically the square roots when you round it to 10th place to make it more accurate. So 2.6 plus 5 is 7.6, 7 plus 2.2, 9.2, and it's less than. But you can also do this. You could say, okay, so I just copied down the 5 here. So you could say, square root of 7 sits in between square root of 4 and square root of 9. So it sits in between 2 and 3. So if I just rounded it off and said, let's go estimate and say it's 2.5, I'll go right in the middle. 2.5 plus 5, 7.5. On the right side, the square root of 5 is between 4 and 9, which is 2 and 3, and I say, let's just say it's in the middle. It's not, but let's just say it is. It's still less than. You could have done, I don't know if I want to go any more into this and make it any more confusing, but sometimes you have to be really accurate, sometimes you don't. Okay, I think I don't want to confuse anybody any more than I already did. Let's go to 18. Okay, 6 plus the square root of 8, it's actually 2.8, so you would have 8.8. Square root of 6 is 2.4 plus 8, so it's less than. If you said that's close to 9, which is 3, 6 plus 3 is 9. This part, we'll call it 6, we'll call that's 9. The square root of 6, square root of 9 is 3, square root of 4. So see how it's kind of in between? So you could call it 2.5, and it's going to be 10.5. It's still less than. I hope that's not confusing, but you got to look at those and you got to think. What's the square root of 6? Well, the square root of 6 sits in between square root of 4, square root of 9. 4 is 2, 9 is 3. From here to here is 2. From here to here is 5. It's 2/5, so it's like 2.4. Yeah, and there's 2.4. So, I don't know. These are difficult. I would never teach that to 8th graders, even though I am, because it's in the book, so I did, but it's confusing. No two ways about it. So you could literally do what we did where we estimated the square root. Square root of 8 sits in between the square root of 4 and the square root of 9. You could do all that estimation stuff and you could get these numbers and you'd round it off to there and round it off to there. You could do it that way. Okay. What the heck did I do here? Holy Moses. Okay, so what I did here was I took the same problem and I said, okay, like I was talking about, Square root of 8 sits in between square root of 4, square root of 9. So 4 is 2, 9 is 3. And you could just say, call it 2.5. You could do that. So you're saying 6 plus the square root of 8. So 6 plus in between these two is 2.5. And you get 8.5. If you came over here and you said, okay, let's go over here. Don't look at that. Okay, square root of 6 plus 8. So 8, I just brought it here. And then I said, okay, square root of 6 sits in between square root of 4, square root of 9. So it's in between 2 and 3. And we'll call it 2.5, even though it's really, yeah, it's close. So 2.5 plus 8 is 10.5. And 8.5 is less than 10.5. And if you did it really accurately by getting the square root of 8, which is really that when you round it, and that when you round it, you still get the same answer. So sometimes, as long as you got less than, you're okay. Sometimes you got to be a lot more accurate, sometimes you don't. So, I don't know. This should be taught to high school kids, but what do I know? Okay, so on this one, the square root of 4 is 2, and there it is. So the square root of 4 is 2, 2 minus 2 is 0. So over here, if you look at this side here, you're saying 4 minus the square root of 2. The square root of 2 is 1 point something. So I would stop right there and go, done! Because that's going to, let's say it's 1.2. 4 minus 1.2 is 2.8. Isn't 0 less than 2.8? You know, whatever this number is, the only way you'd have you would change anything is, watch. Let's say this was a square root of 16 right here. And I wrote it over here. So if this part right here, and it was saying instead of 4 minus the square root of 2, it was 4 minus the square root of 16, then it would be 0 and you'd have equal. Because 0 equals 0. You see how I'm saying if this right here was the square root of 16. So if that was the square root of 16, that would change the whole problem, and that's what it would look like. Oh, 0 equals 0. But it's not, because I wrote if up there. Okay, so since we're looking at this, let's go over it again. The square root of 4 is 2. There it is. 2 minus 2 is 0. Okay. 4 minus the square root of 2. The square root of 2 is 1 point something. Let's look at it. 2 square root, it's 1.4. We'll call it 1.4. So if you put a 4 here, 4 minus 1.4 is 2.6. 0 is still less than, whatever this is over here, you're multiplying, you're subtracting a number that's less than 4. Even if your answer was 0.01, 0 is still less than no matter what your answer is over here, as long as it's greater than 0, it's going to be 0 is less than the right side. And this number is not, it's not like over here where it was 16. It's a small, I don't know if I'm helping or not, but I'm trying. Okay. If you look at that about, I don't know, 1, 2, 3 million times, it'll probably make sense to you. All right. When you see it next year, you're going to go, oh, right, it's getting easier. Okay, they want you to go least to greatest. Okay, well, 81 is 9, and that's already just the number. The only one I got to figure out is 72 over 7. And if you divide that somewhere, 72 divided by 7. See, when it's not typed in, it's not that pretty. 7 goes in, 7, 7, 7, 7, bring down the 10 and 2 sevenths. Okay. And if you needed to, you could make the 2 sevenths into a decimal. Take 2 divided by 7, and you would get 10.28 or whatever it is. But we don't need to be that accurate, because if you look at the numbers, I can just leave it as a mixed number. So I come over here and I go, all right, square root of 81 is 9. This number stays the same. Okay. The only one I changed that I had to do a little bit of work was 72 over 7 is 10 and 2 sevenths. I didn't need to make this into a decimal, because look at my numbers. 8 point something, 9, and 10. So the 2/7 I can just leave it the way it was. Okay, so now I have what's the smallest, and I'm going to use the numbers in black, the original numbers. 8.9 is the smallest. So then I wrote them like 8.9, 9, and 10 and 2/7. I put them in order from least to greatest. Then I went back and said, all right, 8.9 is 8.9. 9 is the square root of 81. And 10 and 2/7 is 72/7. So using the original numbers, put them in least form of least to greatest. 8.9, 9, and 10 and 2/7. Smaller, bigger, biggest. Okay, let's try this one. Well, 2.55 is not changing, but 7/3 becomes 2 1/3. And over here, I said, oh yeah, 1/3 is 0.33333, so I put a bar over the 3. And the 2.55 stays the same, and the square root of 7 is that fun stuff that you guys love more than anything in this whole world, which is this. Okay, so I go square root of 7, oh yeah, 9 is next door, square root of 9 is 3. If you go down from 3, you get 2, and you square it, you get 4, so I'm just going. Remember, you can do square root of 4 is 2, square root of 9 is 3, or I can just go like I do. Pick whichever one you want. I picked 9, so I went 9 is 3, come down here, 3 is 2, square it, you get 4, and you have square root of 4, square root of 9. Okay, so then my little shortcut is I go like this, and I go, how far is it from 4 to 7? Plus 3. How far is it from 4 all the way to 9? It's plus 5. So it's 3/5 of the way there. 3/5 is 0.6. So I'm calling it approximately 2.6. Do I need to be more accurate? You can do this. Take 2.6 and square it. Take 2.7 and square it. 7 sits in between both of these numbers. Which one's it closer to? It's only it's 0.24, so it's closer to 2.6. And that's what I already had. Okay. Now I come back to here and I go, okay. What happened here? So 7/3 became 2 1/3, and I called it 2.33333, put 2.3 with a bar, and square root of 7 is approximately 2.6. So I went, okay, let's put them in least to greatest. 2.3 is less than 2.5, which is less than 2.6. Makes sense? I got arrows pointing everywhere. 2.3 is less than 2.5, which is less than 2.6. I don't need to be any more accurate. So I go, all right, 2.33 is 7/3. I think I'm allergic to this stuff. Okay, 2.55 is 2.55, and 7/3, or the square root of 7 is 2.6. So this is 7/3. This is 2.55. And approximately 2.6 is the square root of 7. Hopefully that makes some sense. I went quickly. You can rewind it. It's 10:48 p.m. and I need my beauty sleep. Okay, so grading skill. Remember, this is all extra credit. It's only going to help you. You're getting a grade for effort. You're seeing this. We've done it before. You're seeing it again. And you're going to see it again next year, and it's going to be easier next year if you're paying attention. I promise you. Okay, let's go to the next part of this. This is review that we're doing, right? Next module, 2 miles. Oh my gosh, he is hilarious, except for the funny part. Okay, let's see. So this is a review of module 2, exponents and scientific notation. We did some of this we had to move on, and we didn't get to spend enough time on it, but let's do some stuff now. The diameter of the, okay, they want you to write each measurement in scientific notation. The diameter of the Earth at the equator is approximately 12,700 kilometers. Move the point 4 places, see the blue arrows, 1, 2, 1, 2, 3, 4, and you had 1.27 times 10 to the how many places? 4? 4th power. So 12,700 is 1.27 times 10 to the 4th power. We did a bunch of warm-ups on this. We did a lot of stuff in warm-ups, if you remember, on scientific notation. So you move it from the decimal, which is here, and you move it over here, and you moved it 4 places. There's your exponent. 1.27 times 10 to the 4th power. Okay, the diameter of a human hair is approximately 254 hundred thousandths of a centimeter. Pretty small number. Okay, I went to Vegas with $100. I came back with 254. I'm rich. Okay, so you're still going to move the decimal. See how you moved it behind the first digit, so it's 1.2. You're going to put it over here behind the 2, so it's 2.54. But you're going the other direction. Remember how I taught this? If the number is greater than 1, your exponent is positive. If the number is less than 1, your exponent's negative. So you're going to move it. So I have blue arrows over here. You're going to go 1, 2, 3 places. So it's 2.54 times 10 to the small number, negative third power. Big number, positive exponent. Little number, less than 1, negative exponent. And you're going in different directions when you move the decimal. Okay. We didn't spend much time on this, but watch, let's go over it again. We did some of these though. Okay, so when you find the quotient, you could put these numbers in standard form and you could divide them. Or you could just go, wait, divide the decimals. 2.4 divided by 9.6. 2.4 divided by 9.6 equals 0.25. And that's what they got. 2.4 divided by 9.6, you got 0.25. So when you divide these two numbers here, you get 0.25. And when you divide powers to this with the same base, you subtract the exponents. See how they have 10 to the 7th divided by 10 to the 3rd, you subtract the exponents, 10 to the 4th power. You could also do this. 10 to the 1, 2, 3, 4, 5, 6, 7th power divided by 10 to the 3rd power. Cross it out, cross it out, cross it out. You've got 10 to the 1, 2, 3, 10 to the 4th power. So, different ways to do it. Okay, so if you got 2.4 divided by 9.6 and you got 0.25, and you got 10 to the 7th divided by 10 to the 3rd is 10 to the 4th power, here's your problem though. You've got the answer, quote unquote. You think you do anyway. Then you go, wait a minute, that's not scientific notation. Okay, that means I have to move the decimal between the 2 and the 5. And when I do that, see my exponent was 4th power over here? Here it's 3rd power. Every time you move this way, the exponent goes 1 larger. Remember over here, we said 10 to the 1, 2, 3, 10 to the 4th power over here, because we moved it 4 places. When you go the other way, your exponent drops 1. So if we had, if we had 0.25 times 10 to the 4th power right here, and you want to put it in scientific notation, you're going to move it 1 place over and your exponent drops down 1 to the 3rd power. Okay, so let's do this. Write each number in scientific notation. So you're going from here, you're going to go all the way over here, right? Okay. This is your homework, by the way. Number 2, they want you to put it in scientific notation. It's going to be 7.34 times 10 to the something power. Remember, you're going the opposite way. Small number, remember the exponent. Okay, write the number in standard form, the way it's normally written. You're going to go from here that many places to the right. You're going to go that way 4 places. Here, you're going to, the exponent's negative. You're going to go backwards 5 places. It's going to be a small number, point some with zeros and then 133 at the end. Okay, on this one, see that I highlighted the sign? So you're going to simplify the inside. It's going to be something to the 3rd power times, remember, any number to the 0 power is 1. So you're going to multiply those two and then plus, that's going to be, simplify that to the 2nd power. Okay, on number 6, you're going to say 4 plus 2 to the second power over 9 minus 3. Remember when you have third power and you're raising a power to a power, you multiply the exponents? I did something over here. Let's take a look. Way over here with our Wascoey Wabbit. Oh, jeez. Oh, man. What did I do? There it is. Okay, so okay, take a look right here what I have in the box. Okay. They want you to multiply these numbers together. Okay. So when you multiply oh God. Okay, so when you multiply, you could take 2600 and make it into scientific notation. You're going to go from here, 1, 2, 3 places, 2.6 times 10 to the third power. And then when you multiply 2.6 times 3.24, and I just switched the order. You multiply those together, and then you're going to multiply 10 to the third times 10 to the fourth power. And you're going to, when you multiply powers of the same base, you add the exponents. And then you're going to try to put this number, if it's not, like say the answer was 32.6 times 10 to the something power, you got to move the exponent here. If your decimal was here, you got to move it behind the 3, and your exponent goes down. See if you guys can remember that stuff. Okay, remember, it's extra credit, it's only going to help you. See if you remember this. Let's look at, by the way, you know what you could also do? You could take 3.24 times 10 to the fourth and put it in standard form. Then you could multiply these two numbers together, and you could put it back into scientific notation. That's crazy. Either method works. Okay, so I'm not trying to show any more of this stuff because I don't want to give all the answers away. And 7 and 8, I'm going to show you these. Because see how this is to the fifth power, and that's the fourth power, and that's the fifth power? You got to switch this into a number that's 10 to the fifth power. So you'd have 0.125 times 10 to the fifth, something times 10 to the fifth, and then all you're doing is you're multiplying 3.2 times 0.125 times 2.9, and whatever you get, it's going to be, you'll see, I'll show you. Okay, and on number 8, yeah, that's the one I showed you guys. Okay, so let's, in other words, I'll show you guys this stuff, and I'll show you guys this stuff. Just do 1 through 6. Just be careful on 5 and 6. 1 through 4 shouldn't be too bad. And we'll go over this. I have it set up for Friday, but maybe I'll send it to you on Thursday. We'll see. All right then. It's been real. And it's been fun. But has it been real fun? I don't know. Anyway, we'll catch you guys next time.